Have you ever stopped to think about how your phone unlocks with just your face? Or how your email inbox magically knows what's junk and what's important? Yeah, machines are making decisions for us constantly. But how do they actually learn to do that? Let's pop the hood and take a look at the engines that run our digital world.
It all really starts with a simple question, one you and I deal with 100 times a day. A new message lands in your inbox, and in a split second, a decision has to be made. Is this spam? Or is it something I actually need to see? This is the perfect, everyday example of a machine making a judgment call.
So what's making that call? Well, at the very heart of these decisions, there's a special kind of algorithm called a classifier. You can think of it like a digital sorter, whose entire job is to look at a piece of information and put it in the right bucket.
Okay, let's break that down. A classifier is just a program that takes in some information. We call these features, which could be anything from the words in an email to the pixels in a picture. Then, based on those features, it spits out a label, a prediction, like spam or not spam. Simple as that.
Now, this isn't some kind of digital voodoo. It's all about recognizing patterns. The way a classifier works is by learning what we call decision boundaries. You can literally picture it drawing a line in the sand to separate one type of data from another, all based on what it's seen in the past. And you know what? These rules can be surprisingly straightforward. For example, a classifier might learn a rule just like this one. If an email has the word free and it has more than 3 links, then boom, it's probably spam. It's all about finding those little combinations of clues that lead to a really good guess.
Okay, so we've established that classifiers learn rules from data. That's the key. But do they all learn in the same way? Well, no, not really. It turns out, just like people, they have different study habits. Think of it like 2 students preparing for a test. On one hand, you have the eager learners. These are the students who study all semester, digest the material, and create a perfect little summary sheet. They do all the heavy lifting up front. On the other hand, you have the lazy learners. They're the crammers. They basically just memorize all the textbooks and wait until a question is asked to frantically search for the most similar example.
Now, it doesn't matter if a machine is an eager studier or a lazy crammer. All classifiers follow the same basic 3-step journey to become the decision-making powerhouses they are.
First up is training. This is the school phase, where the model just plows through mountains of data to learn all the patterns. Next comes evaluation. Think of this as the final exam. We test it on new stuff it's never seen before to see how well it learned. And finally, there's prediction. This is when the model graduates and goes out into the real world to start making decisions on live data.
And that brings us to a really, really important question. How do we grade that final exam? During that evaluation step, how do we actually know if our classifier is any good at its job?
Your first instinct might be to just check its accuracy, right? What percentage of the time did it get the right answer? But honestly, that can be a huge trap. Imagine 99% of your emails are legitimate. A model that just guesses not spam every single time would be 99% accurate and totally useless. We need a much smarter report card.
And that's where this thing called the confusion matrix comes in. This is our go-to diagnostic tool. It's just a simple table that shows us not only that the model made a mistake, but exactly how it made a mistake. Did it call something spam when it wasn't? That's a false positive. Or did it miss a spam email completely? That's a false negative.
Now, from this matrix, we can calculate much better metrics. The first one is called precision. Precision answers a very specific question. Of all the times the model pointed its finger and said, "That's spam," how often was it actually right? High precision means that when the model makes a positive prediction, you can pretty much take it to the bank.
But that's only half the picture. The other side of the coin is recall. Recall asks a totally different question. Of all the spam that was actually out there, how much of it did our model manage to find? High recall means your model is a great detective. It doesn't let much slip through the cracks.
So here's the catch. There's usually a trade-off between precision and recall. If you try to crank one up, the other one often goes down. So to find that perfect middle ground, data scientists use something called the F1 score. It's basically a clever way to combine both precision and recall into a single number that gives us a more balanced view of how the model is doing.
Okay, so why do we obsess over all these different scores? Because in the real world, the type of mistake a classifier makes can have wildly different consequences. It all comes down to the stakes of the problem.
This table says it all. If you're building a system to diagnose a life-threatening disease, missing a real case, a false negative, is a catastrophe. You want to catch every possible case, so you need incredibly high recall. But for your email spam filter, accidentally marking an important job offer as spam, a false positive, is the real nightmare. So you'd rather let a little junk through in order to have super high precision.
And this is the invisible intelligence that's humming away behind so many things we use every single day. From protecting our bank accounts from fraud to recognizing our faces, classifiers are the quiet workhorses of the modern world, just making sense of all the data, one decision at a time.
So I'll leave you with one final thought experiment to really lock this in. Imagine a self-driving car that's trying to identify pedestrians. Which mistake is worse? A false positive, where the car slams on the brakes for a plastic bag it thinks is a person, or a false negative, where it fails to see a person who is actually crossing the road? Your answer to that tells you everything you need to know about why choosing between precision and recall is so incredibly important.